calculate the wavelength of the photon in nanometers to 3 sig figs when a hydrogen atom in an excited state with n equals 4 reverts to the lowest energy state n equals 1. Okay, so we have an electron that's going from n equals 4 to n equals 1. If we think about this, we can draw something sort of like this, where we have n equals 4 here and n equals 1 there. So we're going from here, and we're going to revert down to the lowest energy level that it can, to n equals 1, right? So what we need to do is find the wavelength for this. So how do we do that? Well, what we're going to do is we're going to use the Balmer-Rydberg equation, and this equation says that 1 over the wavelength is equal to 1.097 times 10 to the negative 2, and that's in nanometers to the negative 1, right? This then will be multiplied by 1 over n final squared minus 1 over n initial squared. Okay, well, n final is 1 and n initial is 4, right? So then this equation is going to be equal to 1 over, that's 1.097 times 10 to the negative 2 nanometers to the negative 1, and 1 over 1 squared minus 1 over 4 squared. Right? This ends up being 1 minus 1 over 16. And so when we do this calculation, we end up getting that 1 over lambda is equal to 0.01028 nanometers to the negative 1. Well, we want to know what it is in nanometers. This is not actually what we're looking for. This is 1 over the wavelength, sometimes called wave number. So lambda then would be equal 1 divided by 0.01028 nanometers to the negative 1. And this comes out being 97.23 nanometers. So that's a pretty small wavelength, 97 nanometers, right? We're talking in the ultraviolet range. So very high energy and very short wavelength. Is this an emission or an absorption? Well, the electron went from n equals 4 down to n equals 1. When it comes down like this, it has to release a photon. And so it's going to release a photon at that wavelength, and that would be an emission. So this is an emission. All right, hope that helps.